So the water equivalent of the calorimeter. So let's see the setup. We want the calorimeter, the sets, an extra beaker, and then a thermometer and a balance. Okay, so this is all we want for the experiment. First of all, we weigh the empty calorimeter, just this. This is the outer jacket. This is the outer jacket. This is the lid. Okay, we don't need this for now. We just weigh the empty calorimeter on the balance, and then plus the stirrer. Okay, plus the stirrer. Then we write the value as m naught. So that gives us m naught. So let's say the empty calorimeter plus stirrer is, let's say, 72.9, right, grams. Then we pour cold water, 1/3 of this, of cold water into this. Okay, so we pour cold water 1/3, right? We pour 1/3, so about this level. Okay, and then we go back and then weigh it. Okay, so let's say we are having, let's say, 100.5 grams for the cold water plus the stirrer plus the calorimeter. Okay, so the next thing we do is to take the temperature of the cold water. Okay, so the next thing is we take the temperature of the cold water. Okay, so we measure it, right? We measure the temperature. Let's say we have 15 degrees, because it's supposed to be ice cold, right? So let's say we have 15 degrees. That's supposed to be theta 1, 15 degrees, right? Then we write that one. Then we pour warm water into this, any amount. This is supposed to be 1/3, but this any amount. Then we take the temperature of this as well. We don't want this to be too hot. Okay, it should be within 50 to 60 degrees, right? The temperature of the warm water, around 50 to 60 degrees. So let's say we had, example, let's say we check the temperature of this warm water, and then let's say we have 60 degrees. That one becomes theta 2, right? Now left with M2 and M3. Okay, so we put this here and then cover it. Now the procedure says we are supposed to let this reach about 15 degrees, 5 degrees below our room temperature. Okay, so we are supposed to let the cold water reach 5 degrees below our room temperature. Okay, 5 degrees below our room temperature. Okay, so example, if our room temperature is, let's say, 30 degrees, okay, now we have to wait for this water, this cold water, to rise from 15 degrees to 25 degrees. Because if our room temperature is 30 degrees, it means that 5 degrees below our room temperature is supposed to be 25. Now this water is 15 degrees, this cold water is 15 degrees. So we are supposed to wait for this cold water to leave 15 degrees, rise from 15 degrees to 25 degrees. So that's 5 degrees below my room temperature. Okay, then we are supposed to wait for this water, this warm water, to also, we are supposed to wait for the warm water to also attain a temperature of about 15 degrees above our room temperature. Okay, 15 degrees above our room temperature. Okay, so if our room temperature is 30 degrees, okay, if our room temperature is 30 degrees, 15 degrees will be 45 degrees. So this water initially, right, is 60 degrees. Now we have to wait for this water, which is 60 degrees, to drop from 60 degrees to 45 degrees, right? 45 degrees, because 45 is 15 degrees above the room temperature. Okay, so we are waiting for this water to drop from 60 degrees to 45 degrees, whilst we are waiting for the cold water to rise from 15 degrees to 25 degrees. That's the concept. At the same time, we need to get there at the same time. So we can stir this, right, then be checking. So what we do is we can just insert the thermometer here and be checking. Is it coming? Then we check this. right? We can check this and we check. If you have an extra thermometer, then you can use two thermometers separately for this. Whilst you are checking this, right? So if you don't have an extra thermometer, I can just use one thermometer and then check this. Then you also check this. When they get to the temperatures we want at the same time, okay, when this one gets to 45 degrees and this gets to 25 degrees, this and this gets there at the same time, then we uncover this, right? Then we start mixing. Now the temperature of the mixture that we are supposed to have is supposed to be 5 degrees above our room temperature. Okay, the temperature of the mixture is supposed to be 5 degrees above our room temperature. So what we'll do is, now that we've gotten the temperatures that we want, we put this thermometer here, right? Now this have reached 25 degrees. Since this have reached 25 degrees, I just need a little amount of this to mix with this, right? To mix with this to give me 35 degrees, because my room temperature is 30 degrees, and then the mixture is supposed to be, this mixture is supposed to be 5 degrees above the room temperature. Okay, so once I mix and I get the 35 degrees, then I stop. I take this out, right? Then I'll go and weigh this on the balance, right? When I weigh this, the mixture, that becomes my M2. So let's say, example, let's say that one gives me 120.1. Then the temperature that was 5 degrees above my room temperature for the mixture becomes my theta 3. Theta 3. Okay, so these are the values. Now when you get these values, we are supposed to use this value in this equation. In this equation, right? We use it in this equation, the equation here, right? And then this is the water equivalent of the calorimeter. All these parameters, we have them from here. So we can make W the subject. Don't expand, because it will gonna be long. When you expand, it will be very long. So what we do to make this, to make W the subject, we just divide this side by this so that this can cancel out. Then this, it comes here, this comes here. Then we remove these brackets and then send this one there and send this one here, like this, to get an expression like this. And then we plug in the values to get our W. Okay, there is no graph for this experiment, so this is the water equivalent of the calorimeter, and then this is how it is done. Thank you.